All right, this is our first attempt at the flip classroom for the AP Stat class, and we're going to deal with independent events, the section 5.5. The resources you're going to need for this are the PDF that's on the web page, and there are 3 Khan Academy videos linked to this. The first one on independent events is basically the similar problem that we're going to go over to, where Sal Khan is using dice, or he's using the coin instead of dice. And then he's got another video where he sticks strictly to dependent events, and then he contrasts them. So we're going to begin actually at the end and say, consider this question. Are these events independent? You have 2 dice. They can be different color. I mean, this is actually a problem right out of the FST book. Rolling a 2 on the first die and having a sum of 7 on both dice. Would those events be independent? So, we're starting with the answer here. We're going to work back to where we got this. But this makes sense to you. The probability that I got a 7, given that the first die came up with 2, is 1/6. Why? Well, the first die is row 2 here. So the only way I get a 7 is here, row 2, column 5. So given that I got a 2, there's a 1 out of 6 chance of that occurring. The probability of getting a 7 before you began was 6 out of 36, which is this diagonal, northeast to southwest. But 1/6 equals 6/36, which is confirming that these events are independent. And we're going to go to the PDF for the lesson and walk through the algorithms. So these are the topics in the textbook section you're accountable for in the AP test. Right? And just to review from section 5.3, the probability of A or B is their sum subtract the intersection, because that would be counted twice. So you take it out. Disjoint. If you have disjoint, which is mutually exclusive events, the probability of A and B occurring together is 0. So therefore, you would have this expression subtract 0, and it would just be the sum of the probability A plus the probability of B. The probability of A and B is the probability of A times the probability of B given A happen. Now, if the events are independent, then the probability of B given that A happened equals the probability of B. And that's what we saw in the dice example. So if you have independent events, then the probability of B given A, you can substitute just the probability of B for that. So this is true. The probability of A and B happening equals their product if and only if A and B are independent events. Now, in terms of a two-way table, when we're calculating the two-way table, we've got row 1, column 1, row 1, column 2. Row 2, column 1, row 2, column 2. What values go in there? Well, row 1, column 1 would be the product of the sum of the row times the sum of the column divided by the total, and for the other cells as well. These are the questions you're going to go to. D27, P38, P41. We're going to pause the video, give you a chance to do each of those questions, and go back to the solutions one at a time. Okay, so pause it, and then we'll go from there. D27. Suppose that you randomly, independently select 3 houses from those sold recently in the Chicago area. Find the probability that all 3 houses are below the median price. So the probability that 3 out of 3 are below the median, meaning half the homes sold for less than that value and half sold above. So the probability that I choose one house that's below the median is 1/2. And the probability that the second house is below the median is 1/2. And the probability that the third house is below the median is 1/2. Their product is 1/8. Find that at least, what's the probability that at least one of them is below the median price? Well, instead of calculating the probability that at least one is below the median, it would be easier to say, let's find the probability that they're all above the median and subtract that from 1. So the probability that they're all above the median is the same as if they were all below. That's 1/8. 1 subtract that, 7/8. So, first answer that you go 3 for 3 below the median is 1/8. Second answer is 7/8. And, we can use the binomial menu to calculate the first one. Gives you the same answer. That's 27. 38 is asking, suppose you draw a card at random from a standard deck. Use the definition of independent events to determine which pairs of events are independent. So, A is asking, get a heart, get a jack. So if we organize our information in a two-way table, and we say, okay, the jack is columns. Yes, I got a jack, no, I got a jack. The heart is a row. Yes, I got a heart, no, I got a row. We can organize the information this way. Are these independent? Getting a heart. Well, the probability of getting a heart is 1/4. The probability of getting a jack is 1/13. The probability of getting a jack and a heart, their product is 1/13 times 1/4 is 1/52, but there's only one jack of hearts. So the probability of getting that is 1 out of 52, which is confirming that these are independent events. B is asking, get a heart and getting a red card. The probability of getting a heart is 1/4. The probability of getting a red card is 1/2. Red and a heart. The probability of getting a red and a heart is 1/4, but that does not equal the product of 1/4 times 1/2. So therefore, those events are not independent. And C is asking, getting a 7 and getting a heart. The probability of getting a 7 is 4 to 52, 1/13. The probability of getting a heart is 1/4. The probability of getting both is their product, 1 out of 52. But they're independent because there's only one 7 of hearts. So we're going to pause it and then come back to problem 41. Okay, question 41. About 11% of college freshmen have to take a remedial course. Suppose you select 2 freshmen at random and check to see if they have to take this course. A, find the probability that both freshmen selected at random have to take the course. So the probability the first child has to take the course is 11%. And the probability that the second child has to take the course is 11%. So the probability that both have to take the course is that product, 11% squared, which would give you 121 10,000ths, a little over 1%. And they ask us to take that information and summarize it in a table. So we have a two-way table. Freshman number 1 is the column. Freshman number 2 is the row. So the answer for part A gets pasted here in the intersection. Yes for 1, yes for 2, that's where you would be. As we work across, freshman number 1 is a no, freshman number 2 is a yes. So that would be 89% for freshman 1 times 11% for freshman 2 would give you 979 10,000ths. The sum of row 1 is 11%. In the same way, the sum of column 1 is 11%. If freshman number 1 does not have to take the course, it's an 89% chance, and freshman 2 does not have to take the course, that's also 89%. 89% squared gives you 7,921 10,000ths. The sum of the no column is 89%. The sum of the no row is 89%. And then the grand sum is 1. Question C says, how could that help you answer B? And the answer to B is that exactly one freshman has to take it. So if exactly one freshman has to take it, it is this cell, which is freshman 1 no, freshman 2 yes, plus freshman 1 yes and freshman 2 no. Sum of these two cells tells you that's the probability that precisely one of the 2 freshmen had to take the remedial course. So the plan is for you to familiarize yourself with these examples and the exercises, check out the Khan Academy video, and when we get to class, we will spend that time working on the homework problems collaboratively.